In this lecture, we'll be discussing a solved problem on process synchronization. So this is a problem that was asked in GATE 2010 CS paper. Alright, so let's see what is this question and let's see how we can solve this. So in the question it says, consider the methods used by processes P1 and P2 for accessing their critical sections whenever needed as given below. The initial values of shared Boolean variables S1 and S2 are randomly assigned. So here we are given two processes P1 and P2 in which the method they use for accessing their critical sections are given below. So here this is the method used by P1 and this is the method used by process P2. So we see here that S1 and S2 are shared Boolean variables. They are shared between processes P1 and P2 and this will be used for accessing their critical sections. So the initial values are randomly assigned. And what is the method? Let's see. So for process P1, it says here, while S1 equal to S2, and then we see a semicolon here. That means as long as S1 is equal to S2, that means whenever S1 and S2 are the same, then P1 will not be able to enter its critical section, but it will be stuck in this while loop. So we see the semicolon here which says that as long as this condition is true, the control remains inside this while loop. And the moment this condition becomes false, P1 will be able to enter its critical section and do its operation. And after it enters its critical section and completes its operation, it will come out of the critical section and it will set S1 equal to S2. So this is the method used by P1 for entering its critical section. Now let's see what is the method used by P2. So in P2, here it says while S1 is not equal to S2 and we have a semicolon here. So it means here that as long as S1 and S2 are not the same, P2 will not be able to enter the critical section, but the control will remain in this while loop. And the moment this condition becomes false, and when will this condition become false? When S1 will be equal to S2, that is the opposite of this. At that time, it will be able to enter this critical section and do its operation. And once it completes its execution, it will set S2 not of S1. That means S2 is not equal to S1. So this is the method used by P2 for accessing its critical section. Now we have understood the methods used by processes P1 and P2. Now let's see what is the question and how we can solve it. So the question is, which one of the following statements describe the properties achieved? So here we have four options and it is asking us which of the statements describe the properties achieved. So option A says mutual exclusion but not progress. Option B, progress but not mutual exclusion. Option C, neither mutual exclusion nor progress. And option D, both mutual exclusion and progress. So we see that there are two properties that are mentioned here. One is mutual exclusion, the other one is progress. So the first option says that we are achieving mutual exclusion by the methods followed by P1 and P2, but we are not going to achieve progress. And option B says we are achieving progress but not mutual exclusion. And option C says we are not achieving mutual exclusion nor progress. And option D says we are achieving both mutual exclusion and progress. So in order to solve this, first let's recall what are the meanings of these two properties that we are talking about, mutual exclusion and progress. We have already studied about this in the lectures of this process synchronization. So let's just recall that. So if we just recall, we can see that we have already studied mutual exclusion means if process PI is executing in its critical section, then no other process can be executing in its critical section. That means only one process can execute in its critical section at one time. So that is what we mean by mutual exclusion. And what do we mean by progress? So progress means if no process is executing in its critical section and some process wish to enter their critical sections, then only those processes that are not executing in their remainder sections can participate in the decision on which will enter its critical section next, and this selection cannot be postponed indefinitely. So by progress, what we essentially mean is that when a process wants to enter its critical section, some other process which is not in critical section or which is executing in the remainder sections should not participate in the decision making of who should enter the critical section. So let's see if this mutual exclusion and progress are satisfied in the methods that we saw for the processes in our problem. Alright, so let's see here. If you look at the methods used by processes P1 and P2, we see that in process P1, if S1 is equal to S2, then it will not be able to enter the critical section. And it will be able to enter critical section only when S1 is not equal to S2. And then in process P2, we see that while S1 is not equal to S2, it will not be able to enter the critical section. It will be able to enter only when S1 is equal to S2. So we see here clearly that mutual exclusion will be achieved, because for P1, only when S1 equal to S2, this condition, when it becomes false, it will be able to enter critical section. But for P2, when S1 is not equal to S2, only when this condition becomes false, it will be able to enter the critical section. So we see the two different conditions here, and it is clear that both of them cannot be in the critical section at the same time, because when one condition is true, the other becomes false. So both of them cannot be in the critical section at the same time. So mutual exclusion is achieved for sure. So we can say that mutual exclusion is achieved. So before we go to the options, let's also see if progress is achieved or not. As I already described to you, progress means when a process is wanting to enter the critical section, the other process, if it is not in its critical section or if it is in its remainder section, should not involve in allowing or disallowing the first process from entering or not entering the critical section. So let's see if that is happening here. So let's take an example. Let's say that process P1 wants to enter its critical section. So it comes here and it checks if S1 is equal to S2. So let's say that this condition is false. S1 is not equal to S2 and it is able to enter the critical section. So it enters its critical section, and then after it enters, it will set S1 equal to S2 and then it comes out of the critical section. Now let's say after that, again this same P1 wants to enter the critical section, but P2 does not want to enter the critical section. So P1 wants to enter the critical section again, but P2 does not want to enter. So let's see what happens here. The final value is S1 equal to S2 that was set by P1. Now when P1 will try to enter critical section again, it will check is S1 equal to S2. The condition is true because it was set by P1 that S1 equal to S2. So this condition remains true. So it will keep looping inside this while loop and it will not come to this critical section. Now when will it be able to enter critical section? Only when S1 is not equal to S2. And when will S1 not be equal to S2? Only when P2 will set the value of S2 not equal to S1. Only when P2 enters its critical section and then it will set S2 is not equal to S1. Only at this point the value of S1 and S2 will be unequal. And only at that time this condition can break and P1 can enter critical section again. So we see that even though P2 does not want to enter critical section, P1 has to wait for P2 to again enter here for setting this condition so that P1 can go to the critical section again. So P1 unnecessarily is going to have to wait for P2. So P1, even though it wants to enter critical section again, it is not able to enter. It is stuck here. And it has to wait for P2 to do something and set this value S2 is not equal to S1. Only then it can enter. So we see that P1 is unnecessarily waiting for P2, and hence we see that progress is not achieved here. Even though P2 does not want to enter the critical section, P1 entering the critical section is still depending upon this P2, which is not what we want in progress. So progress is not satisfied here. So we see that mutual exclusion is satisfied, but progress is not satisfied. So what are the conditions that is achieved here? Let's see the options. Option A, mutual exclusion but not progress. Yes, this itself is correct because we are achieving mutual exclusion but not progress. And option B says progress but not mutual exclusion. This is not true because we have mutual exclusion. And C says neither mutual exclusion nor progress. We know that we are having mutual exclusion. And it says in D both mutual exclusion and progress, which is also not true because we are having only mutual exclusion, not progress. So anyway, we found that option A is correct, so we don't even need to check B, C and D. So the correct answer here is option A. So that is how you find the solution to this problem. So you just need to analyze the codes carefully of the methods used by processes P1 and P2. And you just need to also keep in mind the definitions and the meanings of the properties that we have, like mutual exclusion, progress, bounded waiting and all those. So if you have all this in mind clearly, then you will be able to analyze and solve this easily. So I hope this was clear to you. Thank you for watching and see you in the next one.